First, the record. On the morning of March 28, 1979, a reactor near Middletown, Pennsylvania, melted about half of its core. No one died. The Department of Energy states it plainly. No injuries, deaths, or direct health effects were caused by the accident. What this file cost, it cost in trust. This is the station, on an island in the Susquehanna River. Cooling towers, 2 domed containment buildings, and inside the second one, a pressurized water reactor running that morning at about 97% power. Nothing here is broken yet. The design first. A pressurized water reactor keeps its coolant liquid by keeping it under enormous pressure, and one tank does that job, the pressurizer, at the highest point of the primary circuit. On its head sits a pilot-operated relief valve, which lifts if pressure climbs too high and is meant to reseat when it falls back. At 36 seconds past 4 in the morning, feedwater pumps trip on the non-nuclear side. The turbine trips. Pressure rises. At about 7 seconds, the relief valve opens exactly as designed, and at 11 seconds, the reactor trips. Every single thing so far is correct. If you would rather understand why things fail than watch them fail, subscribe. A new failure is drawn here every week, each one a reason you are safer than you know. And this is the room where it was read. An inspector at the instrument panel days after. Look at that wall of lamps. One of them, somewhere in that field, was reporting something that had not happened. Here is the flaw, and it is a wiring path. The lamp for that relief valve was driven from the solenoid circuit that commanded it. When pressure fell, the controller dropped the signal, the lamp went dark, and the panel read closed. The light reported the order that had been given. It did not report whether the order had been obeyed. There was a second untruth from the gauge they trusted most. Pressurizer level was rising because steam voids below were pushing water up into that tank while the system as a whole drained out the top. Level up, inventory down. And this plant had no direct indication of water level inside the reactor vessel itself. Now the load, and here the load is heat. Fission stopped at 11 seconds, decay heat did not. Emergency feedwater pumps started within seconds, but 2 valves left shut after maintenance blocked the water, and that went unnoticed for 8 minutes. Emergency injection opened a third path automatically at 122 seconds. At 279 seconds, drilled never to let the pressurizer fill solid, the operators throttled it back. The procedure was followed. The picture was wrong. Here is the line. Coolant out of the primary system, up through the pressurizer, out through a valve the drawing has already labeled closed, down the tailpipe to the drain tank, through a burst rupture disc, onto the containment floor. Drawn once. Circulation was lost when the coolant pumps had to be shut down on a steam and water mixture. By about 6 in the morning, the top of the core uncovered. Shown here only as the drawing, the water line receding, fuel channels going from hatched to void. At 22 minutes past 6, a relieving shift supervisor noticed the tailpipe was abnormally hot and closed the block valve upstream of the relief valve. 2 hours and 22 minutes, the leak stopped. One person reading a temperature instead of a lamp. The physical record. Post-accident examination found at least 45% of the core melted, about 62 tons, with roughly 19 tons relocated to the lower head, some of it above 2,600 degrees Celsius. The vessel showed a hot spot about 1 meter across and held. So did the containment. The President's Commission held that the accident began with equipment failures, but turned serious because of training, procedures, and a control room whose design made the plant's actual condition hard to read. The official finding is no detectable public health effect. Some peer-reviewed studies and many residents dispute it. The record has not closed. And here is what changed. Valve position indication became position indication, direct sensing acoustic monitoring, tailpipe temperature. The exact flaw in this drawing was designed out. Reactor vessel level instrumentation was added. Procedures went from event-based to symptom-based. Control rooms were rebuilt around human factors, and operators now train on a replica of their own. Failure mode. Indication failure. Valve position inferred from a command signal. Every control room built since has to answer one question this one could not. Is the valve actually shut? Nothing breaks without a reason. Now you know this one. Drawing filed. Like and subscribe to support the channel.